Special types of factoring. In order to begin factoring special polynomials, let's first dissect the multiplication of conjugate pairs. This is also called the product of a sum and a difference. We have the sum of two numbers and the difference of two numbers, and we're taking the product of those. Remember that when we multiplied those, the middle terms, the o and the I of the FOIL method, end up canceling out, and we have just a squared minus b squared. So when we have conjugate pairs that multiply together, the result is called the difference of squares. Why would they call this a difference of squares? If you look at this, this is a square, 4 is a square, and x squared is a square. 49 is a square, and we're taking the difference of them. So it's a difference of two squares. You can see over and over how this happens. We multiply the first two, the outside, the inside, the last. The outside and the inside always cancel out, and so we have the difference of squares. Same here. The outside and the inside cancel out, and we have just the first and the last. So looking at this backwards, the difference of squares, when we start with this, is going to factor as the product of a sum and a difference, or as conjugate pairs, where we have the same numbers here but opposite signs for their middles there. So let's factor this. It's a difference of squares, so we know we'll have two sets of parentheses, and I'll have one here to multiply together to be z squared, and I have a number here which would be 10. Okay, 10 times 10 is 100, and then we have a plus and a minus. If we wanted to check, we could do that. It'd be z times z is z squared, minus 10z plus 10z is 0z, and 10 times negative 10 is a negative 100. Here we have another difference of squares. It's going to factor with parentheses here. The square root of this goes here and here, and the square root of this is going to go here and here, and opposite signs. Remember, these are conjugate pairs, or you can think also that when we're factoring a difference of squares, then the factors will have different signs. Here's another difference of squares. 625r squared, that is the square of 25r, so that's going to go in our first spot. And 121t squared is the square of 11t. And of course, different signs from each other. Now, can x squared plus y squared be factored? Let's try something like that. Let's say we had something like a 4m squared plus 9. How would we factor something like that? We could try 2m plus 3 and a 2m plus 3. But as I FOIL this out, I get a 4m squared plus 6m plus 6m plus 9, and that gives me a 4m squared plus 12m plus 9, which is not what we wanted to factor, so it definitely does not factor that way. Let's say that we tried a 2m plus 3 and a 2m minus 3. If we do that, we have a 4m squared for the first term, a negative 6m, a positive 6m, and a negative 9. Collecting like terms, the middle goes away like I want, but I have a negative 9, not a positive 9. So this can't be the way to factor that either. One thing left to check is maybe we could try 2m minus 3 and 2m minus 3. So 2m times 2m again is 4m squared, a negative 6m, a negative 6m, and a positive 9. Collecting like terms, I have a middle term which I don't want, so this can't be the factorization of that either. We have exhausted all the possibilities for this to be factored with real numbers, so it cannot be factored with real numbers. What we'll just say when we see something like this and we're asked to factor it is we'll say prime. Just like your prime numbers 2, 3, 5, 7, they're numbers that can only be divided by themselves in 1. This polynomial can only be divided by itself in 1. Perfect square trinomials. For any real numbers a and b, a squared plus 2ab plus b squared equals a plus b quantity squared, and a squared minus 2ab plus b squared equals a minus b quantity squared. Here are some examples of perfect square trinomials. Perfect square trinomials will always factor as a binomial squared. Okay, when we were squaring binomials, then we always got 3 terms. So we're just taking this backwards. So where does the first term of the factored form come from? Where does this come from? It's going to be the square root of this. 2x is the square root of 4x squared. 7x is the square root of 49x squared. Where does the last term of the factored form come from? Right here, it's the square root of this. 3 is the square root of 9. 7 is the square root of 49. 9 is the square root of 81. And what will the middle sign of the factored form be? It's going to be the same sign as the middle. So if this is a positive, it'll be positive. If this is a negative, this is going to be negative. See? Positive, 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 negative, negative. So how could we quickly check to see if we have factored correctly? What we could do is square this, and then we multiply those together, which is 5x, and multiply it by 2, or double it, so that makes 10x, and that's our middle. So basically just multiply back out to make sure that we have factored correctly. So let's factor the perfect square trinomials here. I know I'm going to have a binomial squared. I'm going to take the square root of this and put it here. The square root of this, put it here, and the sign here is going to be the sign for my factor. And let's check it real quick. So we squared, we get a negative 5 squared is a positive 25. And then for the middle, x times negative 5 is negative 5x, and double that, it's negative 10x, which is what we started with, so we're good. Let's try factoring this. I know it's going to be some binomial squared. 25x squared factors as 5x times 5x, so I'm going to put a 5x there. And 36, the square root of 36 is 6. Of course, this is a plus, so this will be a plus. Now to check, let's multiply those together. 5x times 6 is 30x. Double it is 60x. So I definitely have this factored correctly. Let's factor this perfect square trinomial. So the square root of 25y squared is 5y. The square root of 4z squared is 2z. And my minus sign is going to have to come down here. So I have a 5y times negative 2z is a negative 10yz. Double that is a negative 20yz. Observe the special product of these factors. This will be interesting for you. Again, we're going to multiply everything in the first set of parentheses by everything in the second set of parentheses. So first I'll multiply the 2x through everything. I get 2x times 4x squared is an 8x cubed. and I get a 2x times negative 14x is negative 28x squared, and a 2x times 49, I get a positive 98x. Now I'll move to the 7 and multiply that through the second set of parentheses. 7 times a 4x squared is a positive 28x squared. 7 times negative 14x is a negative 98x. And 7 times 49 is a positive 343. Now when I collect like terms, I only have one term that has an x cubed in it, but I have a negative 28x squared and a positive 28x squared, which completely cancel each other out. And I also have a positive 98x and a negative 98x, which completely cancel each other out. So then I'm left with just a positive 343. It's interesting how the middle of this just collapses and we have the first and the last terms. So what we'll be looking at is something that starts like this and we'll have to get it factored like that. What you'll notice about this type of polynomial is, first of all, it's two terms, but 8 is a cube, x cubed is a cube, and 343 is the cube of 7. First, we call the product of those types of factors a sum of cubes. We also have a difference of cubes, and this is how they factor. For any real numbers a and b, here's my sum of cubes. You can see we have a cube, and we're adding them, so a sum of cubes. Factors as a plus b times a squared minus ab plus b squared. And a difference of cubes. We have a cube, and we're taking the difference of them, difference of cubes. Factors as a minus b times a squared plus ab plus b squared. So our factors end up being the same, it's just the signs that are different. But how is it that we're getting from this to all of this? Well, what we'll do here is we're taking the cube root of this first number and put it here. And we're going to take the cube root of this number and put it here. And then we kind of just forget about this for a moment. We're going to take these two numbers. We square the first one, put it here. So we're going to take it and square it, put it here. We take this one, we square it and put it here. And then we multiply those together and put it here. So to remember the placement of the signs, since the numbers are all going to be the same, found the same way, the way to remember the sign is using SOAP. SOAP means that our first sign is going to be the same as this. So it's going to be the same here. If this is a positive, this is a positive. If this is a negative, then this is a negative. So here's our S, and then the next sign is going to be opposite, O. So if this is positive, this is negative. Since this is negative, this will be positive. And the last sign we see is always positive, positive, positive. So let's start with factoring the sum or difference of cubes here. We have here a sum of cubes, and we know it's going to factor as a binomial and a trinomial. So we first take the cube root of this, and that's going to go here. So the cube root of x cubed is x, and we take the cube root of the 125, and we put that here, and that's a 5. Then we kind of forget about this for a second. We're going to take this, square it, and put it here, so x squared. We're going to take this and square it and put it here. Then we want to multiply these together and put them here. X times 5 is 5x. And same as that, opposite of that, and always positive. If we wanted to check this, we could come over here and simply multiply those factors together. Let's go ahead and do it with this one just to make you feel confident that we did factor it correctly. X times x squared is x cubed. X times negative 5x is a negative 5x squared. X times 25 is a positive 25x. 5 times x squared is a positive 5x squared. 5 times negative 5x is a negative 25x. And 5 times 25 is 125. Collecting like terms, I have an x cubed. Negative 5x squared and positive 5x squared cancels out. 25x and negative 25x cancels out, and so I just have the positive 125 left, which is exactly what we started with, so we know for sure we have this factored correctly. Let's practice with this one. It's a difference of cubes, but really not much different. We're going to have our binomial and our trinomial. And we take the cube root of this, put it here, so we have an m. We take the cube root of this, and we're going to put it here, so that's a 4n. And then we take this, square it, put it here, m squared. We take this, square it, put it here, so we have a 16n squared. And we multiply these together and put it here in the middle, so it's a 4mn, and signs are going to be same, opposite from that, and always positive. Again, if you wanted to check, you just multiply those out and collect your like terms. Let's try factoring this one. It doesn't look like anything actually very special right now because 16 is not a cube, x to the fourth is not a cube, 54 is not a cube, and x is not a cube. But we do have a greatest common factor. In fact, if you'd like to use your calculator and find the greatest common factor of 16 and 54, you can do that. You go under Math, go over to Number, and scroll down until you get to GCD. So GCD, and then we put 16, comma, 54, close the parenthesis, and it's 2. So we have a 2 in common as far as numbers, and an x in common for our variables. So our greatest common factor is going to be a 2x, and that leaves me with 8x cubed minus 27. Now we're in good shape because this is a difference of cubes. So I'm going to carry this 2x down. The greatest common factor is still a factor that has to be carried along with everything. And I'm going to take the cube root of this, which is 2x. I'm going to take the cube root of this, which is 3. And then square this, put it here. Square this, put it here. Multiply this together and put them in the middle. And this will be the same sign as that, opposite sign as that, and always positive. So that finishes your lesson for special factoring. Go ahead and try your homework and let me know if you have any questions.